For any homework-related queries, call us at +1 678 648 4277. You can mail us at info@mathsassignmenthelp.com, info@mathsassignmenthelp.com, or reach us at https://www.mathsassignmenthelp.com. Problem 1. The final breakdown. Suppose the 6.042 final consists of 36 true/false questions worth 1 point each, 1 induction problem worth 15 points, 1 giant problem that combines everything from the semester worth 49 points. Grading goes as follows. The TAs choose to grade the easy true/false questions. For each individual point, they flip a fair coin. If it comes up heads, the student gets the point. Martin and Brooke split the task of grading the induction problem. With 1/3 probability, Martin grades the problem. His grading policy is as follows. Either he gets exasperated by the improper use of math symbols and gives 0 points, which happens with 2/5 probability, or he finds the answer satisfactory and gives 15 points, which happens with 3/5 probability. With 2/3 probability, Brooke grades the problem. Her grading policy is as follows. She selects a random integer point value from the range from 0 to 15, inclusive, with uniform probability. mathsassignmenthelp.com. Finally, Tom grades the giant problem. He rolls 2 fair 7-sided dice, which have values from 1 to 7, inclusive, takes their product, and subtracts it from 49 to determine the score. Example, Tom rolls a 3 and a 4. The score is then 49 minus 4 is equal to 37. Assume all random choices during the grading process are mutually independent. The problem parts start on the next page. Show your work to receive partial credit. A. What is the expected score on the exam? Solution. 36 halves plus 1/3, 15, 3/5, plus 2/3, 15/2 plus 49 minus 4 asterisk operator 4 equals 18 plus 3 plus 5 plus 33 is equal to 59. The expected score on the exam is the sum of the expected scores on the individual problems. X test score equals X MC score plus X IND score plus X giant score. The expected multiple choice score is just the sum of the expectations on 36 coin tosses. Since the coin is fair, the expected number of heads on each flip is 1/2. Therefore, X MC score equals 36. 1 divided by 2 is equal to 18. mathsassignmenthelp.com. The expected induction score is a weighted sum of the expectations on problems graded by Martin and Brooke. Let M be the event that Martin graded the problem, and B be the event that Brooke graded the problem. Therefore, X IND score M equals 0.2/5 plus 15/3 divided by 5 is equal to 9/15. X IND score B equals sigma I1/16 equals 15 halves I equals 0. X IND score equals X IND score M PR M plus X IND score B PR B equals 9 1/3 plus 15 halves 2 divided by 3 is equal to 8. The expected giant problem score is the expectation on 49 minus the product of rolls of 2 fair 7-sided dice. We can pull out the constant 49, and, since the dice are independent, the expectation on the product of the rolls becomes the product of the expectations on the rolls, which is 4 in this case, average of numbers 1 to 7. Therefore, if R is the random variable representing the roll of a single die, x, giant score, equals x 49 minus r2 equals 49 minus x, r2 equals 49 minus 4, 2 equals 49 minus 16 is equal to 33. Therefore, the overall expectation is x test score equals 18 plus 8 plus 33 is equal to 59. mathsassignmenthelp.com B. What is the variance on the 36 true/false questions? Solution. Since the coin flips are independent, we can sum the variances of each flip. var MC score equals 36 1/2 1 divided by 2 is equal to 9. C. What is the variance on the induction score, given that Martin graded the problem? Solution. Using the equation var x equals x x2 minus x x2, var IND score equals 152 3/5 minus 9, 2 equals 135 minus 81 is equal to 54. D. Argue why the Markov bound can be used to determine an upper bound on the probability that the score on the exam is greater than or equal to 80. You do not need to compute the actual bound. Solution. The Markov bound can be used if there is a lower bound on the possible values of the random variable. In this case, all test scores are greater than or equal to 0. Use the Chebyshev bound to determine an upper bound on the probability that the score on the true/false questions is greater than or equal to 24. mathsassignmenthelp.com Solution. If C be the random variable representing the multiple choice score. Problem 2. Woodchucks chucking wood. All woodchucks can chuck wood, but only some can do it well. 1/3 of all woodchucks like to chuck wood. 2/3 of all woodchucks can chuck wood well. 1/2 of those that like chucking wood can do it well. The expected amount of wood chucked by a woodchuck, randomly chosen with uniform probability, is 7 kilograms per day. The expected amount of wood chucked by a woodchuck that likes chucking wood but can't do it well is 1 kilogram per day. A woodchuck that does not like chucking wood does not chuck any wood at all, regardless of its woodchucking skills or lack thereof. mathsassignmenthelp.com A. What is the probability that a woodchuck, randomly chosen with uniform probability, likes chucking wood, given that it can do it well? Solution. Let L be the event that a woodchuck likes chucking wood and C be the event that a woodchuck can chuck wood well. We are given PR L equals 1/3 PR C equals 2/3 PR C L equals 1/2. We wish to find PR L as C. Using Bayes' rule, we have B. On average, how much wood would a woodchuck chuck if the woodchuck could chuck wood well? Solution. Let W be a random variable representing the amount of wood the woodchuck chucks. We are given, in units of kg/day E, W equals 7 E, W, L intersection U equals 1. mathsassignmenthelp.com Using the law of total expectation, we can partition the sample space into 3 events. 1. The woodchuck can chuck wood well. 2. The woodchuck can't chuck wood well but likes chucking wood. 3. The woodchuck can't chuck wood well and doesn't like chucking wood. E W equals E W C PR C plus E W C intersection L PR C intersection L plus E W C intersection L PR C intersection L. 7 equals E W C 2/3 plus 1 PR C intersection L plus E W C intersection L PR C intersection L. Since a woodchuck that doesn't like chucking wood does not chuck any wood, whether or not it can do so